Коллеги, добрый день. Рад вас всех сегодня приветствовать. Сегодня мы поговорим и обсудим тему, которая занимает...
So let's discuss the topic that many companies have been dealing with, pilot trains. It's a huge area of operations, lots of challenges, lots of technical challenges, organizational challenges. They're quite difficult to solve if you're alone. So we have been active negotiations with our colleagues, with our partners. We have invited our colleagues to understand where we need to go and how we need to go there, and how to solve the challenges. So the first speaker I'm going to invite is a representative of Roche. We have been looking together as SNCF. I would like to thank Mr. Roche for his cooperation, for the cooperation of his team. I would like to ask him to share his vision and tell us about our cooperation and the projects in France. So, Monsieur, you have the floor.
Yes, thank you very much, Pavel. Yes, do you hear me? Okay, so it's a great honor for me to attend this roundtable discussion. We regularly discuss with our colleagues of RGA and are very impressed by their works on autonomous trains. So it's always for us a great chance when we have the opportunity to share ideas and results with our Russian colleagues. Yes, I want to give you some words about the French program of autonomous train. Our goal is to obtain a prototype of GOA4 train in 2023. And at this date, we want to have solved all the technical barriers. So next slide, please. Yeah, thank you very much. So first, what is our vision of the future? For us, in the future, all train will be an autonomous train because the additional cost for autonomy will be sustainable and because the advantages of the autonomy will be very high. In the first step, the GOA2 level will be deployed each time there is problem with the saturation on the line. Then GOA3 or GOA4, that is totally autonomous train, will be deployed on freight trains, on little regional lines, and on technical trains. And at the end, each train will be GOA3 or GOA4. Indeed, autonomous trains offer a big improvement in capacity and quality, and is less expensive. For example, in France, between Paris and Lyon, on the high-speed line, we have today 13 slots per hour or per direction. With the signaling system ERTMS, we will increase the number of slots and we will have 16 slots. And with ERTMS and GOA2, we will have 18 slots. So another example, for freight train, we can reduce the cost of the train with GOA4 by 30%. In fact, with autonomous train, we increase the productivity of the assets, rails, and engines. So next slide, please. Yes, at SNCF, in fact, we launched 4 projects in parallel. The first project is a project about the signaling, the line-side signaling, and we want to read automatically the signaling. And the second subject is the obstacle detection. There are 2 big barriers in the way to autonomous train, and we are focused on these 2 subjects. The second project is a project of a remote controlled train. We are convinced that remote control is necessary with GOA4 because the supervisor of the GOA4 train will be able to remote drive the train in case of hazard. And our 2 other projects are our bigger projects. The first one is the goal is to have an autonomous train with passengers, a prototype in 2023, and the other one, the same thing with a freight train. Yes, thank you. The next slide. Yes, I don't see the slide, but on the next slide, we want to show what is our ecosystem. In fact, we are not alone to develop autonomous train. And for each project, we constitute a partnership with SNCF, with industrials, with research institutes, with French public authorities, and we want to find the experiences, to find the competencies where they are. With the French public authorities, we are working about safety, about cyber security. And we share very frequently with other railway companies, especially with EB and with RGD. Last but not least, we take part in the European works in Shift to Rail, where we work on the standardization. It's very important for us. We contribute to specify autonomous train. So please, the next slide. Yes, just to finish, I would like to highlight 4 important subjects for us. First thing, we work on the evolution of professions and its support. What does it mean for our driver, for our staff, autonomous trains? It's an important subject for us. What does it mean, the new job of supervisor of autonomous train? Second subject is the safety. Safety is very important. In fact, it's not difficult to have an autonomous train. The very difficult things to have is an autonomous train with an homologation with the right level of safety. The key question is the demonstration of the safety. There is 3 subjects with the security or safety: the safety of the train itself, the security of our passengers, and the cyber security. Third aspect is the definition of European standards. I have already spoken about that. And the last but not least, And the last one is a customer support. How could we do to have passengers without fearing coming in an autonomous train? How can we show to our future passengers all the advantages of autonomous train? So with these 4 examples, I want just to show you that our project is not only a technical project, but it's a global project with social aspect, with economical aspect, and we have to deal with all these aspects. Thank you very much for your attention.
Laroche, большое спасибо.
Thank you very much for your presentation, a very interesting presentation. Thank you for mentioning our collaboration as well. Yes, clearly it is very important to involve not only the technical but also the social and the economic aspects. And now a very brief question to you. Looking at your presentation, I see that by the year 2030, you intend to start unmanned trains in France. Therefore, by year 2030, we will see a full-scale implementation of this project by SNCF. Is that right? Do I understand you correctly?
Sorry, Pavel, but I don't understand because I am at the same time English and Russian.
Попробуй по-русскому, потом на английском спроси.
I'll try asking this in Russian first. According to your presentation, SNCF intends to introduce full-scale unmanned trains by year 2030.
Большое спасибо за выступление. Прошу оставаться.
Thank you very much. Please stay with us. Please participate in this discussion. Now I would like to give floor to Deutsche Bahn, Mr. Jacobs. We are in very close contact with them as well. We're discussing various tasks, objectives. We have a very fruitful cooperation. I would like to thank Mr. Basilis Jacobs for this collaboration. Please, could you tell us about the project of Deutsche Bahn in the area of unattended trains? What have you been able to achieve? What are your plans for the future at Deutsche Bahn? Thank you.
Yeah, thank you very much, Pavel. Also, Luke, thank you very much for your presentation. I'm really impressed about, let's say, the development of SNCF, and I'm also very impressed about what's going on in Russia, having a lot of discussions with Pavel regarding to ATO, and Pavel, thank you very much for your invitation here. I feel really honored to be able to discuss this round. And I'm more delighted to have this exchange with the Russian, with you, with the Russian Railways, and especially your department. since I really must say we learned a lot about ATO from you, from the Russians. Since from our point of view, you are very advanced in ATO technology, maybe also, to be honest, a little at the moment more advanced than in Europe. So really, my congratulations to that. As you know, in Europe, we have this big Shift to Rail program initiative. Where we, at the moment, as Luc Laroche said, defining the standards for ATO. Started with the standards from ATO GOA2, tested the standards on ATO GOA2. And now our next step is to standardize and test and establish the standards of GOA4. As Luc Laroche showed in his presentation, and this is the reason why in Europe demonstrators, or let's say tests, industry tests, projects like Luc Laroche are very important, because it's not about just defining the standard, it's also about testing the robustness of the standards and the applicability of the standards. And this is the reason, and we already had a lot of discussions about that, Pavel, how important testing is and how important it is to have prototypes and do very, very iterative and often testing. Yeah. Since it's a really new innovation, and and it's a really new field where I really appreciate our collaboration also with SNCF and Russian Railways, since we all working on the same goal to establish APO as soon as possible. I don't have a presentation like Luc Laroche, but I fully agree to everything what has been said and presented by Luc Laroche. I fully agree to my European colleague. And therefore, I want to show you from our point of view a video of our last DB cargo shift to rail freight test. Goal of this test last year in Switzerland was to test the specification of GOA2 for freight, since specification for GOA2 for passenger, from my point, and metro trains is very has a high maturity. But from my point of view, for freight GOA2, it's not that much experience in GOA2, and we really need to challenge all the GOA2 for freight. I especially want to highlight here that a freight train is every day has new parameter, new lengths, different loadings. And means that every day with a new constellation you have a new mass dumper system of a freight train. which is really, from my point of view, a big challenge for the feedback control and the algorithm of GUA2 to control this mass damper system. And furthermore, you're dealing in freight with a lot of longitude forces coming from the freight train. And you have also, comparing to passenger, you have different brake systems. For example, the dynamic brake, the direct air brake, where you brake the train, the loco with air, and the indirect air brake, where you have with air to brake the wagons. And the application of these different brakes is also a challenge for GUA2, because it's the question how you apply or imbalance or this different brake. A good example is, for example, if in GUA2 you're not first braking with the air brakes the wagons, and instead of that braking with the dynamic brake the locomotive, then the wagons will push the locomotive, let's say, even if the locomotive is braking, and that maybe cause a derailment, for example, in front of a switch. And therefore, there are some challenges for GUA2 for freight application, where I'm confident that we can handle that, just from that point of view. And this is what we tested in our GUA2 test demonstrator, the application for freight. The existing technology to understand the readiness, and what we also tested in our demonstrator, their interoperability of ATO means interoperability. Can I run with the German train on another country infrastructure like Switzerland? And since in Europe we have histories in infrastructure and different setting of infrastructure, it's a big challenge for us. And the second, what we tested is it possible to realize standard interfaces to the train for APO? Like plug-and-play interfaces, like you plug an ATO system on the train like a USB stick, and this was also the question. For GUA2, of course, we did not test it for GUA4. And for that, we tested together with Bombardier as vehicle supplier, and with 4 other suppliers: Alstom, Siemens, RGD, and Hitachi as ATO GUA2 onboard supplier. We tested the applicability and realization of such standard interfaces.
Modulus, sorry for interruption. Yeah. 1 minute left.
Okay, is it still, so it's not possible anymore to show you the video?
Okay, short video and the end.
It's 4 minutes, okay.
We are in charge of providing a highly efficient international infrastructure which covers all the needs of a modern society. Humanity is currently facing a variety of challenges. One of them is the pollution through CO2 and the resulting climate change. Despite the efforts of the past years, a lot more has to be done to reduce emissions by at least 55% by 2030. A significant increase in rail transport will be one major key factor because rail transport results in 80% less CO2 emissions compared to truck transport. To fulfill the expectations, an increase of capacity, productivity and reliability of rail freight is needed. For this, the automatization of processes is key. The Shift2Rail Automated Rail Cargo Consortium, led by Deutsche Bahn, brought partners together for the integration and testing of automatic train operation. SBB, Alstom, AGD, Bombardier, Hitachi, Siemens and Thales cooperated, modifying a freight locomotive from the Trax platform in Mannheim, Germany. Despite COVID and resulting travel restrictions, the test runs were conducted successfully and enabled system tests under real operation conditions on test tracks between Sierra and Sion in Switzerland. The successful completion of testing automatic train operation is an important milestone for more rail freight in the future. We are proud of contributing our share to a sustainable future by strengthening rail freight with dedication and passion.
Thank you very much for that.
Большое спасибо, Базилиус.
Thank you, Basilios. Very interesting presentation, especially thankful for our unlimited discussion of architecture, standardization, and the time we committed to discussion, how to connect technical vision, perception, positioning. The question of standardization is very crucial. I'd like to know that Deutsche Bahn and Basilios in particular participate actively within association. It's available, accessible for everyone, and Shift2Rail project also with the open information. And truly, I'm saying that area of unattended trains is very important to understand and develop common approach and common scheme of architectural solutions of the locomotives. And now I'd like to organize a survey that we used in our colleagues' discussion. I'd like to show on the screen, and I'll voice out. If we switch to the systems, Goa 3, Goa 4, then there is technical vision. What are requirements in terms of safety we need to apply to technical vision? The level of safety, CO2, CO3, CO4. Please vote. I hope that majority knows the completion of safety procedure. Please show me results on the screen. The winner is CO4. My opinion is, we discussed with Deutsche Bahn and Basilius, that correct CO2. And if we access level of train driver, maximum for him is CO2. Very arguable and difficult question that I need to prove together, convince together, and solve together what is the level. CO4 is very high level, and there is a number of the questions difficult to overcome. Now I'd like to invite a presentation to tell about development of the Russian railways. Pavel Melnikov, you're welcome. Come to the platform. Can you launch presentation, please? Good afternoon, colleagues. The path we walked to development of automated train. Other presentation, I'm sorry. The electric train that yesterday and today you were able to ride, today and yesterday, the Goa 3 Plus started back in 2015 in the project an idea that how we can provide automated train, automated shunting locomotive at the shunting yard. This idea went through 2 years. In 2017 at Luzhskaya Sortirovочно-Oktyabrskaya railway corridor we launched first unattended shunting locomotive with certain limitations. In 2017 we started to work on technical vision. For this purpose, the shunting engine, at the same time second branch unattended passenger transportation. By 2019 at the Moscow Central Ring we tested train with levels of automation GO2 and detected certain technical features which under condition of operation require a review of the very approach to creation of the construction of electric train. Together with Urals locomotives plant, we design 36 with the level of automation GO3+. Today, by 2022, together with Urals locomotives, we switch to the last gradation, GOA4 electric train, where we take into consideration all technological processes, impact of the train driver onto the driving system. No less important factor is that unattended movement is out, infrastructure is impossible. Infrastructure allows to assist technical vision, to assist control system with all the informational signals that usually are controlled by the locomotive driver. GOA4 implies that all control of the doors is embedded into automated system. For this purpose, at Stop Krymskaya MCK, we launched project with this set of sensors. Which allow, with the help of neural network, control any changes that take place in the door opening, such as jamming of people, jamming of luggage, jamming of pets. Geo 3+, we need to move to GOA 4. In Russian Railways Corporation, on the 30th of March, Sergei Kobzev signed decree which determines types of obstacles that should be detected by the technical vision system. However, this classification does not allow to set the requirements towards technical vision in terms of the distance of obstacle, not only pure human being, but automobile, and any deviation of infrastructure from the initial status. At the same time, we know human specifics, the sharpness of vision. Because of the sharpness of vision, a man can see further. And there is a number of requirements. A man at 1,100 meters with ideal vision can see another man on infrastructure. These things regarding what requirements should we apply against technical vision in terms of distance where we should detect obstacle, it is necessary to discuss and regulate normatively. The electric train 36 is made of a big number of apparatus systems, hardware lidars that allow to, with the help of laser, scan surrounding environment, number of optical cameras, because we understand that at the braking distance of electric train with maximum speed at MCK 110 kilometers per hour, distance is 600 meters, we need to see rather far away. So 8 optical cameras equipped with different focus lenses cover all ranges from nearby to far away. With all these things, we don't forget about man, because the train driver, as integral part of electric train, must move further. Within this objective, we create situation center. The situation center that provides monitoring of entire infrastructure and all automated trains. In this situation center, we create new professions. The operator driver, operator working with passengers, addresses. On each train, at the intercom, the train driver is answering the passengers. In foreign railways, there are special operators who talk to the passengers, so we move as part of automation. Every operator driver simultaneously can monitor state of 4 electric trains. At the same time, in the event if there are accident, contingency, the operator focuses his attention to one train because he remotely controls one train. What shall we do with the 3 other? For this purpose, we have senior operator driver. They will provide this objective to hand over trains that are not operated by the first operator. So it's retraining of personnel. So with the Directorate of High-Speed Transport, with PKBL, we form job descriptions. Presentation is on. Please, number 6. Next. These roles are described by the slide. We retrained people. Good. Next, we need to organize infrastructure. Communication network is the backbone of the system that allows the train to receive and send information to the situation center. Due to the fact that we have dedicated by Russian Railways 1,100 megahertz, MCK finishes construction of this communication network. We conduct first testing on this dedicated network. We separate the circuit of control of the Lastochka train as the single independent segment independent of the communication operators. Big number of the curves we see on experimental Sherbin ring allows us to realize one more infrastructural project, a stationary complex of detection of obstacles. In case if technical vision on the curve doesn't see more than 600 meters, it means that we need to, ahead of time, feed the system with knowledge regarding whether there is obstacle or not. The system is implemented as permanently operated system. The system of boarding and discharging of the passengers as part of automated system, when we can remove a man from the train. Because of this, we finish circuit infrastructure, personnel, and the train that is ready for operation in fully automated mode. But one of the objectives that we set back 2 years ago, during the same conference, how to provide minimal delay during the transfer of video signal. Pandemics help us. All of us were at the distance working, IT companies were working on organization of the distance working. They organized minimum discomfort. On the market, we had big number of new codecs and new approaches which we implemented in the project and provided delay of video signal to driver no more than 300 milliseconds. Unattended train. How do we test such trains? Today, there is no detailed requirements as to what our conditions surrounding train should be, so we can conduct testing. Next slide. One of the parameters that we discovered for ourselves is visuality. Is parameter that can be measured with the help of additional equipment that we install onto infrastructure. The sensor of visuality will determine gradation, the grades within which we should apply additional requirements towards the technical vision system. Besides the visuality at the night time, if parameter is less than 5 luxes, under condition shown by the visuality sensor, it is also necessary to limit conditions for the operation of technical vision system. But at the next slide, these are scenarios that we can, or rather we face with them, but we cannot model them all the time. Next slide. How to provide, next slide please. How in this case system of technical vision understand where the tracks and what obstacles to detect. Such scenarios is particular at the central ring, much snow. Additional scenario we need also for modeling to provide the indicators of which we spoke and prove safety of the system. Next slide please. For this purpose we created virtual network where we can conduct full spectrum of testing of all algorithms we embed into technical vision system. Together with PKB-CT, for more than a year, we conduct in virtual space testing of all algorithms. And some we created mathematical models, which we implemented the virtual network for virtual train that represent lidars installed onto the train, the same optical cameras with the focus distance. Because of this, we decrease number of iterations we need to carry out at the network and get rid of the objective to bring elk or bear onto the rail track. That's all. Thank you, colleagues, for participation. We have opportunity to test those scenarios of which I spoke. Next slide. As the outcome, we achieved rather good results. The train that we use for passenger transportation travel, more than 5,000 kilometers, in automated mode around the Moscow Central Ring, all prototypes of technical vision and systems within the electric train. We realized integration of electric train with intellectual system of safe boarding and discharging at Krimsky train station. We realized high precision system of technical vision that is also integral part of the system of technical vision and system of automated driving, which provides the mode of GO2. We realized the automated cleaning of sensors, as which I spoke. This is what we faced with 113 train and what we implemented on 136 train. Through analysis of signals from all sensors, we automatically, like in automobile, start the glass cleaners, sensor cleaners, and the machine controls the process, which provides visual control of distance. Implemented optical camera on the roof for the pantograph control. For the drivers, we have feedback from the drivers who test our trains. They like the idea very much. They feel more comfortable to work with electric train. With all this, next slide. We should not forget about the regulatory framework, implementation of such technology as the complex, with infrastructural facilities required, elaboration of the prohibitions with which we face to implement in mass such automated trains. There is no direct prohibition, only regulation that limits us in terms of installation of certified equipment onto electric train, but we gradually remove limitations through certification of equipment. Indirect limitations, existing PTM edition, all the works related to amendments already underway. There is an order from Russian Railways. In 2022, we'll switch to new edition of PTM that includes distance control and driving and systematic operation of the trains with passengers. That is why all the approaches of which I spoke are integral parts of the ladder on which we climb in order to make a product that people are not afraid of, that will allow to switch to the aspects of which our foreign colleagues spoke. Thank you very much for your attention. Thank you very much, Pavel. Thank you for your presentation. I hope at the end we'll have time for discussion so that we can ask questions. I give the floor to Smagin Igor from Siemens to tell.
Павел, спасибо большое.
Pavel, thank you very much. I would like to clarify. I'm going to do a joint reporting to my colleague Karl-Heinz Scholz. He's in Germany now. He's going to join us remotely. And to set the note, I would like to share two pieces of news with you. One news is good, the other piece of news is not so good, as the joke goes. So, in August, Siemens Mobility signed an agreement to introduce unmanned technologies between two countries, between Singapore and Malaysia. So we can say already that year 2021 is the year where unmanned technologies will have started connected countries, and I congratulate all of us on this. So Russian technologies will also be capable of doing this. As for the second bit of news, also in August, the world saw the trade union of train drivers carried out 2 strikes, and unfortunately, this resulted in serious transport collapses. We have already discussed today that when we discuss unattended trains, we should not forget the social factor. The social factor manifests itself in 2 ways. As the previous speaker said, we need to start thinking today already about the fact that we're going to have new train operator jobs, train operator professions. On the other hand, we as manufacturers see that such incidents open a large field where we need to convince the customer that we need to introduce unattended train technologies. So our report will consist of two parts. I will look into the history of this topic to understand whether this is dreaming or this is a reality. And my colleague will tell about the present and the future of Siemens technologies. Now, to reduce the timing, I will not dwell on the project that we already discussed today with colleagues from DB. Yes, Siemens was involved in the pilot project on automatic freight transportation. As many experts present here know already, Europe, but also the entire world, has a very clear division between the TCS and CPTC. What is used for metro transport, for mainline transport. So this slide also shows our projects that we launched together with the Swiss railways. And in the UK, the Chainslink project. When Siemens started to introduce technologies over ATCS. I would like to dwell very briefly on our joint projects with Russian Railways on Luzhskaya station. In that project, we carried out unmanned control of shunting operations. And our collaboration with Russian Railways does not limit itself to our contractual obligations. Furthermore, as part of introducing this technology, we at Siemens signed an agreement with Russian Railways to obtain the results of the intellectual activities. Moreover, some of you may have seen the other day that Siemens has been implementing the unattended streetcar technology in Germany. And I can tell you that the control system, and it is important to bear this in mind, this system should not exist independent of the infrastructure. So the station processes system, the yard management system used at the Luzhskaya station will be used, among other things, in the project for the unattended streetcar in Germany. And now I would like to give floor to my colleague in Germany, Carlsson. The stage is yours.
Thank you very much, Yury. Good afternoon, ladies and gentlemen. Just to give you a bit of context again, although I'm sure you are aware of the grades of automation, just showing that from left to right, the grade of automation is increasing from 1 to 4, and as it is increasing, the systems are becoming more complex and the functionality are more comprehensive. Now, the grades of automations 3 and 4, as discussed, are already state-of-the-art in metro systems. However, they are much more difficult to handle in a mainline environment. The main differences are that the metro environment is mostly a controlled environment. There are also uniform systems in a metro where we have the same operator and very similar vehicles. And of course, metros are designed to transport people and not freight. All these facilitating factors are missing in a mainline environment. In the mainline environment, you have an open alignment with an unprotected guideway. We have open platforms and potentially intersecting traffic from roads or pedestrians. At the same time, the systems, the vehicles are not homogeneous. They are diverse from different suppliers and different manufacturers. And you have a mix of passenger transportation together with freight and cargo transport. Furthermore, the operating rules on the main based on manual operation principles. So it is the big challenge when we look at driverless operation on the main line to consider all these more difficult and more complex environmental factors to provide safety and passenger comfort. What is required to tackle these challenges, I show on the next slide. Basically, we see many systems that have to act seamlessly together and work as one system to make safe and reliable operation with driverless technology possible. So first of all, we have the train protection system, which is doing the positioning information and the speed information. In combination with obstacle detection and handling, where it is analyzed what is around the train and what is moving, what is static. Then a big importance comes to artificial intelligence. All these sensory inputs have to be processed and have to be evaluated. Meaning that optical sensors like cameras, as well as proximity sensors or even lasers, need to be collated and need to be analyzed by a computer system which can apply patterns and can also learn from more and more inputs. And finally, you need to put this information into control action so that the automatic train can do the right things at the right time, like braking in time to stop at the point of danger and accelerating as it is possible on the line. All of this is, of course, only possible if one system is closely interconnected with the other system, and that's the complexity to give a full integration of all different systems, be it from the rolling stock side, be it from the train control side, or even from peripheral systems in the stations and along the line. Just to give you a brief overview of what Siemens is doing regarding driverless application on the main line or in open terrain, I have prepared an overview on the next slide, which shows that we are and have in the past already deployed several driverless systems, even on a tram or on a mainline train. And we are currently implementing driverless operations for depot and stabling in a tramway context. The next steps are, of course, developing the system further, and later in 2025, we are looking at implementing the first fully driverless mainline train in public operation in the Berlin area as part of the Digital Railways in Germany initiative. So what are now the pros and cons, the advantages and maybe disadvantages of a driverless system? Certainly there are optimizations possible in cost and in maintenance. This results from the trains being driven more economically and in a way more efficiently than a human driver could. and that a driverless system can also very well be used to save energy. We increase safety by eliminating the human factor and human errors. And there is an increase in capacity for faster turnarounds and potentially also, if you get rid of the driver's cab, to use the space for passenger seating. Also, in a driverless system, it is easier to react to changing demand of transportation capacity. It's easier to deploy trains without a driver than having a crew management and needing to take care of drivers' availability. And certainly it is also a factor of prestige and of showing this face of modern technology for a city or a region or a country. However, of course, there are also limiting factors or disadvantages.
Carlsson, 1 minute, please.
Thank you. We see that a more complex and more autonomous system requires higher capital expenditure and longer project durations. The time aspect is very much depending on the homologation process, which takes quite a bit longer than for conventional systems. And the economic benefit, the return on investment, is in most cases only directly possible if you have a very large scale operation. Then a very important view from our supplier's perspective is the interfacing and the integration of driverless system on different vehicles. Unfortunately, it's not plug and play. It's for each and every vehicle an independent and individual solution. And it is always mandatorily required to have good cooperation with the original vehicle manufacturer. And a fourth point is that a lot of additional technical equipment is needed both on the train and on the track side. To provide all safety functionality. Thank you very much for your time.
Carlsson, thank you very much. I would like to ask you a question. What was your vote for? SILA 0, 2 or 4? Please tell us. Regarding machine learning question.
I would have voted for, I think it was grade of automation that was meant. I would have voted for GOA3, so driverless but with a train attendant.
Thank you.
Большое спасибо, Юрий Смагин.
Thank you very much, Yury Smagin. Thank you, Carlsson, Scholl, for telling us what Siemens has been doing in the area of unattended trains. What I enjoyed in particular was the last slide, which shows the pros and cons of unattended trains. I fully agree with everything that was said there. And now, I'd like to give the floor to Andrey Romanchikov. From Transmashholding. He'll tell us about the latest development of TMH in the area of unattended trains. Good afternoon, dear colleagues. Thank you. Yes, I will begin from Siemens, from the 7th slide of Siemens. This session is about pilotless trains, unattended trains. Is it daydreaming or is it reality? And nobody asks why we need it at all. And why is the train driver is such a bad guy that we need to fire him? We're all here wearing nice suits, nice ties, and we're all here focused on the bad guy, the machine operator, the train operator. No, this is not the right way. Now, getting back to the 7th slide, none of the pros have anything to do with the unattended trains. I will list these pros again. 1, lower operational costs. Well, yeah, we'll definitely be able to save operational costs, but only to a little extent if we fire the train driver. If you take into account only the salary of the train driver, the return on any investment exceeds 50 years, so it doesn't make any sense at all. Wherever we can reduce operational costs, which is due to the system of control and management. This is related to the automatic control, but this is not related to the fact that we need to fire a machine, the train driver. 2, higher safety. Well, yes, we fully agree that automatic systems control better. They're safer. But again, the train driver as a controlling person will not influence this in any way. 3, throughput capacity growth. Well, this is the most interesting argument. Yes, we have this great aim to reduce the interval in the Russian on Moscow metro 3 minutes. So it's also an open question. So the level of automation which we see on mainline transport now, this automatic control system helps us. So it does not limit the throughput capacity. The systems which are used there, this automatic control system, which have been introduced practically everywhere on all the main lines of the Russian railways, don't limit the throughput capacity. So again, this has nothing to do with the train driver. The next argument, the flexible management system. Oh well, I don't know what the train driver has to do with this. If something happened, the train driver can intervene and do it very flexibly, because without any communication, it is much more difficult to ensure flexibility. I hope you remember the rest. So, next, independence from the train operator, which means that if people go on strike, we can continue the movement. Yes, it is an important argument, but I will leave this without any comment. I couldn't remember when a train driver strikes for the past 100 plus years. State-of-the-art technologies are prestigious. Yes, I accept this. Unattended trains look so effectively, so this is prestigious. We've seen this. We saw this yesterday, we've seen this today on this dynamic show, and we will see an attended Lastechka train and 2 unattended Yermak trains. The second train was driving without any train driver in the cabin. So, you know, I've thought about the arguments that you offered, and I was thinking about the best level. The best level of automation. Do we really need unattended technologies in all the modes of transport? Do we need GO4 level? We believe that in the present-day conditions, this is not the best solution. We, as Transmashholding, don't give a positive answer to this. For instance, the commuter trains, we don't think they should be made unattended. For instance, I mentioned the central diameters in Moscow. The cost of introducing the infrastructure, which my colleagues have discussed. And we agree with this set of technical solutions offered, which include a system of data transfer in particular, a system for control over platform space, and the control room. The cost of these systems, if we compare it to the effect, all we can do is basically fire the train driver. So the time it takes to return is well beyond 50 years. And this applies also to the Moscow railroad ring. And Pavel has mentioned this on many occasions. So today, the infrastructure is not ready to go without any train driver. It will take more investments. Is that right?
The statement we will discuss, I have different opinion. Different colleagues have different opinions. That's all right. That's why we believe that Moscow Central Ring, in the view of the Russian railways, think about extra cost for infrastructure to travel without driver. Finishing this introductory part, I have 10 of slides. We will pass them quickly. For the trunk line, we didn't comment on the first one yet. So for the trunk line transport, we believe the level of automation and mass implementation of automated driving and safety devices and virtual coupler system is optimal. That allows to solve the objectives. I absolutely agree with what Siemens said, absolutely correct. But seems to me that can be solved with the driver. And driver, absolutely, if compared to the cost into infrastructure to get rid of it, is not worth it. We keep driver, we have energy efficient moving moment, we have virtual coupler, we have safe movement and flexible controlling and driving system. For trunk line transport, it seems as optimal level, and since this year, all trunk line electric locomotives are equipped on the plant with the systems of automated driving, automated coupler, automated online telemetrics transmission that truly allows to achieve good economical effect. On this venue, it's weird to talk about metropolitan. That was colleagues said, and we agree with them. The automated metro trains are absolutely realistic objective. So, rolling stock and electronic systems for equipping a train, they allow to make it automated. The trains that are being designed near Moscow, they designed from the standpoint of no need for operator. So first of all, it has to do with the automated control of the braking system. For suburban trains, it's a very discussing type item. We support initiatives which are made by the colleagues from NIIAS. However, we believe that the optimal is GOA 2, GOA 3, we believe that GOA 4, suburban train, economically is not clear. Maybe colleagues say, my colleague will speak after me about cheap infrastructure. There is no panacea. If you talk about shunting, industrial transport, then on the closed circuit yards, plants, unattended movement is absolutely reality. New shunting diesel engine, example was shown here, M23, by default equipped with the automated driver with safety systems, automated driving, machine vision. We also present at the exhibition today. And the last, I'd like to once again to tell about necessity to have awaited solutions, and unattendancy is not panacea, and the driver, due to us, due to people who wear suits, unbelievable conditions. If we imagine that every one of us comes to work, sits in the room, and looks in several cameras, he needs to stand up, press buttons. He's responsible for lives of people. Here, I'd like to pose in favor of drivers and wish them health in this very challenging job. Unbelievable. I hope our machinery that we develop the control systems, the driving system will help them to easier and more efficiently do their job. Thank you very much. Andrey Mikhailovich, thank you very much for your presentation. Contradictory opinion. Our discussion seems to be interesting. What's extra? Mikhail said that we need to consider economics. Here I'd like to look at the 7th slide, where savings with broad spectrum implementation, any implementation, when we look at the design stage and implementation stage, look at the segment, it's not always economically efficient. There are a number of other factors to consider. We started to develop system since 2017. The cost of sensors dropped, such as LiDAR, 1 degree. Labor cost going up, unquestionably. Cost of systems becomes the same or drops, so we need to consider it. At some time, what we implement has indirect effect. There's a positioning system, diagnostic system, all this complex effect yields advantage, big advantage. And Andrey believes it's not only trained driver. What else we should note? We need gradually, and I agree, we need gradually to go to level 2, level 3. As to the driver, naturally, no one is going. Don't forget about social question. We need to reconcile automated systems and training. We participated in the session with 115,000 drivers and assistant drivers. Implementation of the system will cut number of the trained drivers. Sorry, you speak as a moderator or developer. You make commentaries. Good example of Rio Tinto. They have different problem. They successfully implemented automated movement. The question is shift changes. It was difficult, and this is the advantage when they spoke about the project. I'm sorry for sidetracking. I have to give the floor to our participant. Thank you very much. Just a minute. We need to discuss 7th slide. We don't want to leave this question unanswered. In fact, I wanted to say that I absolutely agree with Pavel. No one is planning today, tomorrow, terminate train drivers. Talking about operational costs, we didn't talk about salary of the driver after implementation of automated system. But Transmashholding thinks about how much energy locomotive uses. Automated driving, and we perfectly understand the savings is there because automated control is more energy efficient. It's one. Second, as for the headway, I can say that when we implemented Link ETCS level 3 hybrid, we achieved headway 50 seconds between 2 consecutive trains. We talk about dreams and realities. Dreams and realities are this: 500, 600 kilometers per hour. Discussions are on about Hyperloop. The Chinese today with maglev trains. Would be interesting to take a look at them. How at the speed of 600, 700, who reacts better? Automated driver or the human driver? I'm glad that we have a lively discussion. Thank you. Then I give the floor to... Thank you very much. I like the zeal when Siemens talk about automated mode. It is a big cost, it's true. May I have second slide? Answering Andrey's second question, I'd like to say that infrastructure certainly cheaper is not efficiently. First of all, we start from the point of what effect we give to the customer. Just 1 second of advertisement. Looking at the slide, today we talk about Russia from the standpoint of infrastructural on-board solutions. 15-20 group of companies is the only company that has full portfolio of all solutions, starting from the floor equipment, ending with technological equipment and highly intellectual upper-level systems. And this is not only, let's say, slides. This is reality. It's real projects, real case studies. We can handle, touch, and feel, and you can come to our stand. Next slide, please. Let's go back to sorry driver, and people are trying to get rid of. I always ask question. Who asked us about automated mode? Who's the client? Does the customer ask us to do it? And what's behind this unattended and automated mode? It's not only locomotive, it's not only onboard equipment, it's the complex of the subsystems, rather complex systems that interact in different configurations depending on intensity of traffic. First of all, configuration of infrastructure. Today, it's also important point, if you have only locomotive, don't have microprocessor of the interlocking, there's no radio block center, and you cannot reconcile, interlink all these things from the standpoint of customer. The customer will gain risks. What does customer need? I want to cut costs. I want to drive quicker. I want to have more meeting trains. All these objectives set by the customer are clear. Now, very important is the striking balance and offer comprehensive solution he expects from us. Next slide, please. When today we talk about automated mode, before automated mode, there's a mass array of solutions to be implemented. I talk about radio block center, radio interlocking and blocking onboard safety system. I'm talking about that is today. How is this classical systems of microprocessor in center interlocking? The upper level, more intellectual things. These are systems of the traffic process. In our work, we're trying to have more practical approach. You understand there's locomotive, there's onboard equipment, onboard system. We try to reconcile with the infrastructure. It's like a layered cake. Systems overlap with each other, and we come to what customer wants. On automated mode is assistance to driver, accompaniment, and safety system, increase of throughput. I think it's not a secret for anyone. The only solution to assist is realized by a company in Mongolia. You can learn about the system. It's not automated in pure mode, but the system that helps driver, helps customer to ride safely with less costs and absolutely with different throughput that is expected from us. Next slide. I wish to say a couple words. Let's get next. Something's wrong here. 2 words about our new development, intellectual system of transportation process. In essence, in our understanding, before automated, it's integral part of how today the system should be built, an embedded system till the next step, assistance to the driver, and going towards automated mode. We develop the system. In the near future, we'll present it at 2 venues. First of all, it's the system that based on the internal algorithms. Let's say artificial intellect builds imitation model, digital imitation model for different types of rolling stock, increases efficiency, of the timetables, traffic timetables, and organization of transportation process. I'd like to go back one slide. Yes. Very simple, primitive, classical slide when we talk about just first level to increase. The customer primary objection is to pass more trains using existing infrastructure which I already possess in my hands. I want to develop infrastructure through the costs I already incurred, whereas offer efficiency increase. The automated interlocking, radio block center blocking, headway regulation. We add, as I said, as a layered cake, intellectual transportation system. And next is automated driving that has several levels. It was well shown on the Siemens slide. Assistance to the driver without driver and so on. Dependent on where we apply this solution. This is why today it's very important objective that we should resolve ourselves the benefit of automated driving and how this driving reconciles with existing infrastructural systems installed already by customer, including metropolitan facilities, including actively developing tram systems. We must solve this objective for ourselves. And next, automated driving will be drawn by the customer. For now, safeguard all the drivers. Without them, I think today we don't see a real day. Those intellectual systems that vendors offer, reconciliation and comprehensive structural solutions, in essence is the driver and the token of success in implementing of automated driving. Actually speaking, this is all. Pavel, thank you very much for your presentation, and I hope we have some time after all our speakers presented all information. I'd like to draw a survey with consideration of different opinions. The most interesting part, please show the questions. How do you see when we'll have full-scale implementation of automated technology? Laroche answered in 2030. Please show me the question. Tell us, what do you mean under automated? We need to look at the QR code. Can we see QR code? After so many years, we have mass implementation of automated GOA4. Please show me main screen QR code.
Добрый день. У меня для кого-то талончик на обед.
I think it's time to display the results. We had enough time. And we see that on average implementation time is 10 years. De facto, no one has doubt, only 9% that such systems will never be implemented. 90% certain such systems will be implemented, majority believe, during 10 years period. It's quite optimistic timeline. It will be implemented. Many systems have retrofitting of trains, I personally don't have doubts. Organizers, please ask questions from the audience, or those who have online presence. We need microphone on, microphone to the audience. I have a number of questions. May, you don't have questions? Andrey, welcome. In fact, considering unestablished terminology, we have some mix and match of the terminology. I understand automated, there is no man. Automated driving is concrete system of assistance to the driver without man's participation to speed up, slow down in optimal way. For us, in understanding, I speak to the Pavel, is the period, the stage. We cannot imagine any rolling stock in Russian railways. Implemented for 20 years, as I said, anything produced new rolling stock, manufactured in this way. Automated driving is last stage, so that we are on the same page. Please comment.
Здесь с Андреем согласен, потому что вот
I think that, as I was preparing for this report, I saw that machine builders have a very concrete classification, ADAC, 1 level, 2 level, 2 level 3. But here we don't have this uniformity yet. We can interpret unattended technologies in various ways. To me, it's a system when it helps the train driver. Others believe it's without any train driver. And industry standards. This is a question to the Research Institute on standards. Standards would make things more clear. So this this very interesting discussion would be over in no time. Yes, Pavel, thank you. There are 5 levels in motor transport. There are similar standards in the railway transport too. When adapting the international standards to the Russian standards, one more question. Terminology needs to be developed. And we have seen a publication on the terminology for unattended train technologies, because we confuse some terms too. So it is very important to have a document that would regulate both the levels and the terminology that are required to describe the unattended train technology in principle. You know, I would also like to offer a brief comment. Because I have a number of questions. Europe, but also the entire world, see that we have a very wide regulatory framework. There's a very clear division between ACTS and ACTC systems. For instance, what we like very much is that European standard was with Pavel's support translated and introduced in Russia. Well, I think that Russia has got a unique feature to be able to prepare the regulatory framework in the proper way. We have this unique opportunity, and we can even become leaders in this respect. Because, like I said, we don't believe that Russia has been focusing enough on this issue. We're not ready yet from the regulatory point of view. But this is my personal opinion. So, one more question. Okay, I have my last question. So, look, we have been discussing a lot that to create such comprehensive solutions, because it is all interrelated, so interfaces would be the most important aspect. And who would be discussing the interfaces between the rolling stock, the control systems, and all these elements? What do you at the Research Institute believe would be the right approach? You know, I think we need to look back at the initiative where our European peers are involved. Aura, for instance. I'd like to thank you, thank SNCF for telling about this initiative. I'd like to thank my colleague Jakobs for telling about it. So I think that we see the right approach at Accor, where the interfaces between systems become open and open source interfaces. I think we need to take the same approach. We need to work together with Accor. We shouldn't copy them, because from the point of view of the system that they have, SNTC, etc., they have slightly different approach, but the main principles are quite correct. Colleagues, I would also like to ask one more thing. Oh, yes, I hear that our time is up. So I'd like to thank all the speakers for their work. I'd like to wish you all the best in your work aimed at upgrading the railway transport, and let us work together to develop it together. And I wish you all of you the best of luck. Thank you very much, and goodbye.